Welcome to another video on nodal analysis. In this video, our goal is to find the node voltages, and we will be using the Supernode to aid our analysis. Before we proceed to solving the problem, I'd like to ask you to please hit the like button and subscribe to my YouTube channel to support the YouTube channel. Okay, let's begin. So we have five essential nodes, and one is the reference node, and we are asked to find the node voltages. So we can make two supernodes here. We can make a supernode here. That's 1, 2. We can also make another supernode here. 3, 4. Then we have to write equations that connect node voltage V1 and V2 and node voltage V3 and V4. So we notice that V1 is higher in potential than V2 because like the positive terminal of the power source is facing V1. So say V1 minus V2 equals 20 volts. Let's call that equals 20. Let's call that our first equation. Okay. Then say V3 minus V4 equals 3Vx. V3 minus V4 equals 3Vx. Vx is the value of the voltage drop across the 3 ohm resistor. So by knowledge of that, we will know that Vx would be equals to V1 minus V4. So let's write that down. Know that Vx equals V1 minus V4. Okay. So that means that V3 minus V4. That means this implies that V3 minus V4 equals 3 into V1 minus V4. Okay, and that would mean that V3 minus V4 equals 3V1 minus 3V4, and then we would have 2V4a. So that would imply that V3 minus 3V1 plus 2V4 equals 0, and we call that our second equation. Okay. We write that. We can say that minus 3V1 plus V3 plus 2V4 equals 0. Okay, that would be our second equation, I. And then proceed to write KCL equations at our two supernodes. That's this node, this supernode, and this supernode. So we say at supernode 1, 2. Okay, at this supernode. So we write for this branch first. That would be V1 minus V4 divided by 3 plus V1 divided by 2. Then we skip this branch with the voltage source and move over to this branch. So for this branch, it would be minus 10. Then this branch would be plus V2 minus V3 divided by 6, and everything would be equals to 0. And that's the equation at supernode 1, 2. So we can simplify this by multiplying through by 6. If we do that, we would have 2v1 minus 2v4, okay, plus 3v1 minus 60 plus v2 minus v3 equals 0. Then we can rewrite this as 5v1, okay, plus v2, okay, minus v3 minus 2v4 equals 16. We can call this our third equation. Okay, then we can move on to this last supernode. So at this supernode, we can say that let's write it here at supernode 3, 4. So we write for this branch, that we write for this node first, write for this branch, that's v3 minus v2 divided by 6, okay. Then this branch, that will be plus v3 divided by 4. Then we skip the voltage source branch and move over to the other node, and then that would be v4 minus v1 divided by 3, then plus v4 divided by 1, all equals to 0. We can then simplify it by multiplying through by say 20. Okay, let's multiply through by 12. So that would be 2v3 minus 2v2 plus 3v3 plus 4v4 minus 4v1 plus 12v4, all equals 0, okay. Then we can simplify this minus 4v1, okay, minus 2v2 v3 plus 5v3, okay, then v4 plus that would be 16v4, all equals to 0. And we can call this our fourth equation. We are looking for 4 unknowns, and we have 4 equations. We have enough equations to find our 4 unknowns. So from the first equation, we know that v2 equals v1 minus 20, okay, plus v1 minus 20 minus v3 minus 2v4 equals 60, okay. So expanding this, we would have 6v1 minus v3 minus 2v4 equals 80. Equals 80. Okay, let's call this our fifth equation. If we substitute this equation into equation 5, okay, we would get minus 4v1 minus 2 open bracket V1 minus 20 closed bracket plus 5V3 plus 16V4 equals 0. Okay, then we get minus 4V1 minus 2V1 plus 40 plus 5V3 plus 16V4. Then that can be rewritten as minus 6V1, okay, plus 5V3 plus 16V4 equals minus 40. We can call that our sixth equation. So we can solve equation 6, equation 5, and equation 2. Yep, equation 2. We can solve them simultaneously and we'd arrive at the values for V1, V3, and V4. With that, we arrive at the value of V1 to be equals to 26.67 volts, and the value of V2 will be equals to 173.33 volts, and the value of V3 would be equals to minus 46.67 volts. This would imply that V2 is equals to 6.67 volts, and then this was a mistake. This will be V3 and this will be V4. Okay, the value of Vx would then be 73.34 volts. Note that we are asked to find it. So and that will be all for this video. Thank you for watching. See you in the next video. Don't forget to like and subscribe. Bye.